This work presents the design concept and motion planning solution for reconfigurable aerial robotic chains. The design represents a configurable system of systems consisting of multi-linked microaerial vehicles.
Stochastic self-reconfiguration. Robots identical in form,
Hello, good morning, sir. Sir, good morning, sir. Sir.
Very good morning, sir.
Sir, good morning, sir.
ఒక్క నిమిషం శ్రీధర్ ఏదో అన్మ్యూట్ లో ఉన్నట్లుంది. అన్మ్యూట్ లో
Yes, sir.
వినిపిస్తుందా?
Yes, sir.
ఎస్ సార్, గుడ్, వెరీ గుడ్, వెరీ గుడ్.
Okay. Hello.
శ్రీధర్ చెప్పు శ్రీధర్.
Yes, sir. Just hello. So, very good morning to one and all. today is the last day for our 1 week ACT sponsored Atal online faculty development program on robotics. Okay, with valuable kind cooperation of all resource persons and participants, we have successfully completed our 4 days program. Now today, last day, we have to start the session, first session on reconfigurable robot by Dr. V. Veerana sir. 2 days back, sir already covered one topic, robot modeling and simulation on 15th, second session. Sir, on behalf of Atal, ACT Atal Academy and Narayana College, Nellore Department of Mechanical Engineering, once again, warm welcome you, sir, for today's session. As already introduced, sir, 2 days back, and again, just I am going to give very brief introduction. Sir is working with St. John's Engineering College Principal, St. John's Engineering College, Emmiganur, Kurnool District, Andhra Pradesh. Previously worked in various positions in Pullareddy Engineering College and also worked as a principal in various engineering colleges like SSR Engineering College, Ongole, and Srinivasa Engineering College, Kurnool, and also worked as a HOD in Brundavan Engineering College, Kurnool. And Sir has published 30 plus papers in national, international journals, and also attended 20 plus conferences in national and international journals, and also got best paper award in the year 2015. And Sir completed his MTech from NIT Tiruchirappalli and also PhD degree from JNU Hyderabad. With this brief introduction, once again, warm welcome you, sir, to this today's morning session from 9:45 to 11:15 a.m. I request all the participants should utilize this opportunity for enhancing your knowledge in this particular topic, like reconfigurable robot. Welcome you, sir. Once again, thank you, sir.
Good morning to you all. So for the last session, due to some technical problems, so that I have no voice and internet problem. This time I am having my technician with me. So hope I can do better with this topic. So we can start a reconfigurable manufacturing system. Hello, is it visible, sir? Hello?
Yes, visible.
Okay, right. Thank you. So this is manufacturing inventions invented in Michigan. So in 1913, so there is a mass production system which is moving assembly line is introduced in manufacturing system. So first it is introduced in Ford industry. So that is the revolutionary change in manufacturing. So later on, NC machines, numerically controlled machines, so started with 1952 research. Later on, flexible manufacturing system is now is a trend. So later in 1996, the reconfigurable manufacturing system or RMS is going to be introduced. So the future manufacturing system will have a great revolution. So with these technologies, so I have given us a small problem before to need of reconfigurable manufacturing or reconfigurable robot. So because a robot is one of the element in reconfigurable manufacturing system. So what is the need for this reconfigurability? So on screen I have shown 6 machines. So M1, M2, M3, M4, M5, M6. There is a 6 machines. We have to arrange 6 slats: S1, S2, S3, S4, S5, S6 to produce a number of jobs, number of batches. So this is the loading station, this is the unloading station. and we want to produce number of batches, but of course I have given only 6. So suppose J1 jobs are produced to 20 number, J2 is 400, J3 is 300. So like that, if you want to produce, you want to arrange these machines. So what are the different ways to arrange? So these 6 machines in these 6 slots, we can arrange factorial 6. Factorial 6 means 720. So 720 ways the 6 machines can be arranged in the 6 slots, and this 4 jobs or 4 batches want to produce, this is a factorial 6. Factorial 6 into factorial 6, it will be 5,18,400 ways. Hello.
Almost on the way. Maybe it is certainly.
Hello. Sir, please. So other people requested to switch off their voice, please. Okay. So the 6 slots, we have to arrange 6 machines is a factorial 6. So this 6 jobs can be in factorial 6 means, so 5,18,400 ways, that means solutions will obtain. So in this 6 solutions, is it any optimum? But it is not at all possible. We will get only near optimum. If the jobs are going to be increases, if it is a 8 jobs, then it is factorial 8. It will become 2 crore 90,000. 2 crore 90 lakhs 30,400. That's why in a chessboard, if you see factorial 8 into factorial 8, so arrangement it will become 162 crores 57 lakhs 2,400 ways it can be arranged. So now, so suppose job 1 requires machine arrangements M1, M2, M3, M4, M5, M6. If we arrange for in this direction, for a job 2, the sequence required is different. For a job 3, sequence required is different. So then there will have a lot of loss of cycle time and transportation cost. So material has to be moved from one machine to one machine. The cost of transportation is going to be increased. So when I tried to solve this problem in 99, I have seen one paper. So this is the paper, so published by Aventikis and Milan and Solomon MM, a dynamic layout strategies for flexible manufacturing system. It is published in 1990 in International Journal of Production Research in volume 28. What they proved in their research is a study is needed, showed that decrease in material handling cost up to 30% can be achieved by considering regular redesign in FMS layout. So layout, if it is regularly redesigned, that means so machines arrangement changed, then there will have a 30% of the transportation cost can be reduced, and of course even cycle times also can be reduced. But for particular job, if job 1 in the order of M1, M2, M3, M4, M5, M6. If job 2, it is M6, M5, M4, M3, M1, M2. If this can be done, what happens for the transportation cost? Transportation cost, that means material handling cost can be reduced more than 30%. How it is possible? So this is from after 96, I have seen the research institute that, so there is a reconfigurable manufacturing system working on this. So automatically for job 1, this sequence M1, M2 like that. If it is the job or other batch has to be produced, automatically the sequence will be changed in reconfigurable manufacturing system. Of course, there will have some pros and cons problems, so will be there, but they are working towards this. Automatically for one job, it is one sequence. Later on, for second job, second batch production, automatically the machines are going to be changed to the required sequence. So suppose M1 is a lathe, M2 is a slatter, M3 is a shaper, M4 is a milling machine, other one is a grinding machine. How it is changed? Is it possible? So immediately can change from one machine to one machine. So in practical sense, so for traditional machines, it is quite impossible to change the position. So regular redesign, regularly changing once 1 month or 2 months once again we want to change the positions also, it is quite impossible. So because of the reconfigurable manufacturing in future, so this will be a trend, and manufacturing is going to be change a lot in future. So because of that, what is going to be happen? So if the manufacturing time is going to be cycle time reduces and the transportation cost reduces for all the batches. So because of that, what happens? The total cost of the product will be reduced. So that is the need, today's need of today's need in manufacturing. Because of that, we must go towards reconfigurable manufacturing method. So now, so this is an element. Robot is one of the element in reconfigurable manufacturing system. So we have to discuss about the reconfigurable robots. What is the history where it started? Actually, so this reconfigurable robots is started in 1970s, but truly not in sense. But so for one robot, so in general there will have a gripper or a tool, depends upon the application. Suppose for a welding, we will use a welding gun. For a spot welding, we will use a spot welding. For punching, we will use a press. So for any want to load or unload a component, so loading or unloading a component, we will use a gripper. So like that, so each and every activity we have to change the end effector. Instead of that, in 1970s, what they did is for the end effector, they put a magazine. So different tools are going to be arranged, depends upon the activity. Automatically the gripper, that means the tool is going to be changed. That is the seed of reconfigurable robots. So after that, a lot of research is going on. So in 1990 early, these people, Mark Kim, Joseph Michael, Santosh Murra, so these people are working towards reconfigurable robots. So to date, about 30 systems have been designed and constructed, some of which are shown below. So almost number of research labs are working towards reconfigurable robots and of course reconfigurable manufacturing also. So at present up to 2019, so 30 reconfigurable robots are going to be research institutes are produced. So some of the reconfigurable robots which is given, so C-boat, so which is going to be so produced by the author, that means the researcher, in 1988. So many, so polyboat, it is a chain architecture. We'll discuss later what are the different types of robots, architectures, etc. So it is in 1998. So like this, almost most of the all 30 is not given, but some of the robots which are going to be produced up to 2019. So Panthera mobile that means reconfigurable robot is going to be produced. So like this, a lot of research is going on reconfigurable robots. It will be most useful for the students and the faculty who are working in a research area. So now laboratories which are working RRL, reconfigurable robotic lab. So what is reconfigurable modular robot or robot? So reconfigurable robot or autonomous kinematic reconfigurable robots are a autonomous kinematic chains with variable morphology. Self-reconfigurable robots are also able to deliberately change their own shape by rearranging the connectivity of their parts in order to adapt to new circumstances, perform new tasks, or recover from damage. So these reconfigurable robots are going to be arranged or manufactured with small modules or molecules. So they reconnectivity themselves each together. So for to do different activities, perform tasks, etc. So now, what is the need? What is the motivation and the inspiration for research of reconfigurable robots? What are the key motivations? One is versatile. So the modular reconfigurable robot with the many modules have the ability to form a large variety of shapes. In general, so one robot is going to be do for one particular task. Later on, we have to change the gripper or maybe the program. So here, so this modular robots or reconfigurable robots, they can rearrange themselves. So for the variety of shapes to do variety of different jobs. So with the number of degrees of freedom. So in general, so a robot will have 6 or 5 degrees of freedom. If it is a 6 degrees of freedom, so it is a costly. So to reduce the cost of the robot, generally we will reduce the degrees of freedom. But so this reconfigurable robots will have more number of degrees of freedom with less cost. So because of with the modules, so because it is versatile and it is less expensive. So as the number of repeated modules increases, so a small modules or molecules are going to be produced in number same type. So one module is designed, that same module can be produced 10 or 50 or 100. So the expense, the production cost is going to be reduced. So because of that, so expense is reduced, more versatile and more degrees of freedom, and of course it is also reliable. Another result of being modular and reconfigurable is ability of the system to repair itself. So suppose one module is going to be not working so properly, behaving erratically, then that module can be replaced without any cost. So this automatically changes with the another module which is available within the system. So that is more reliable system, and of course it is a robustness also. The robust are interchangeable. So one part is replaced, one part is going to be corrupted, not acting properly, automatically others are going to be interchanged this. So because of robustness, cost is reduced, and versatile, the any activity can be performed without changing of any hardware system. So any program system automatically it does itself. So because this is more uh, more motivated towards the reconfigurable robots. So now we come to the what are the types of robots, so what are the types of architectures which are available in reconfigurable robots. So number of architectures are available: lattice, chain, mobile, deterministic, stochastic, other than so homogeneous and heterogeneous. We'll discuss later one by one. So the first one is lattice architecture. What is lattice architecture? This architecture or this structure has been arranged in some regular 2 or 3 dimensional patterns. So to understand these methods, I will show 2 or 2 minutes, 1.5 minute, 2 minutes small videos to understand all these types of modules. So hope it will be very clear to you to understand this. So this structure has been arranged in some regular 2 or 3 dimensional patterns, such as a simple cube or hexagonal grid. So hexagonal grid, this type. So a cubic or maybe a 2 dimensional hexagonal or some triangular shape which is given here. So hexagonal grid, it makes planning the motions of when and where to move modules and interchanging one from to the other from in possible motions is easy to represent by a computer. but difficult because the space of possible sequences grows exponentially with the number of modules. Because number of modules increases, automatically the space increases, and complexity also sometimes it increases. Lattice architectures usually offer simpler reconfiguration as modules move to discrete set of neighboring locations in which motions can be made open loop. The computational representations can also be more easily scaled to more complex systems. So these are the shapes of lattice structure. So to understand this,
A recent trend in robotics is to get lots of robots working together. But parallel operation is not always enough. Some tasks are just too difficult for the robots to solve on their own. So-called self-assembling robots can combine forces by connecting to each other in a broad range of morphologies. But it's hard for the robots to know when to use different morphologies because of their limited local sensing range. The solution? Flying robots. Flying robots can analyse the environment to see what task needs to be solved, what morphology is most appropriate to solve that task, and which robots are best placed to form the morphology. However, it is non-trivial for the flying robot to communicate with specific robots on the ground. The problem is that the robots have very different views of the world, which makes it difficult for them to agree on a common frame of reference. We have developed a method that allows robots to select their communication partners without relying on any kind of global coordinate system. We refer to our method as spatially targeted communication. Let's say a flying robot wants to communicate with a specific robot on the ground, this one for instance. To start the selection process, the flying robot illuminates its red LEDs. To join the selection process, the robots on the ground light up in blue. In a series of elimination steps, each ground-based robot independently displays a sequence of randomly selected colours. At each step, the flying robot matches the colour of the target robot. Whenever a robot on the ground sees that its own colour doesn't match the flying robot's colour, it eliminates itself. The process continues until only the targeted robot is left. An extended version of this method allows adjacent groups of robots to be selected and then given movement and morphology formation instructions. Here, the flying robot has already targeted the 4 robots closest to the hill and instructed them to form a line morphology. Spatially targeted communication expands the potential of self-assembling systems by allowing ground-based robots to benefit from cooperation with flying robots. Any robotic platform equipped with LEDs and a standard camera can participate in spatially targeted communication. Our current focus is on bringing our research out of the laboratory and into the real world.
so chain architecture. So chain or tree architecture have units that are connected together in a string or a tree topology. This chain or a tree can fold up to the become space filling, but the underlying architecture is serial. Through articulation, chain architectures can potentially reach any point or orientation in space and are therefore more versatile but computationally more difficult to represent and analyze. So I will show a small. This is the units for a chain architecture similar to our chain. So different molecules or modules are going to be arranged in a chain method. So this is chain based design. So some of the designs of robots which are developed.
This work presents the design concept and motion planning solution for reconfigurable aerial robotic chains. The design represents a configurable system of systems consisting of multi-linked microaerial vehicles that simultaneously presents, among others, the ability to cross narrow sections, morph its shape, and allow system extendability. We contribute an approach to address the motion planning problem of such a connected robotic system of systems, making use of its full reconfigurable nature to find collision-free paths in a fast manner, despite the increased number of degrees of freedom involved. The presented approach exploits a library of aerial robotic chain shape configurations, optimized either for cross-section size or sensor coverage, alongside a probabilistic strategy to sample random shape configurations that may be needed to facilitate continued collision-free navigation. Evaluation studies in simulation involve traversal of a room with a window, a maze-like environment, and a connected structure consisting of 2 silos.
So mobile architecture. So we have seen lattice and chain architecture. In mobile architecture, modules detach from the main body and maneuver independently using the environment to link up to the new locations in order to form a new shapes. So from one robot to the other robot, the elements modules can be go to the other one. So here for this architecture, I have not shown any video, but so next one is deterministic architecture. This is other way, deterministic and stochastic architectures. That is the 3 methods: lattice and chain and mobile architecture. Other than this, the remaining way of the classification of robots is deterministic architecture. In the deterministic architecture or reconfiguration, all units moving are being directly manipulated into their targeted locations during reconfiguration. The exact location of each unit is known at all times. So for the computer or the system, so the reconfigure the position of the module or a molecule can be known at any time. So reconfiguration time can be guaranteed, but sophisticated feedback control is necessary to assure precise manipulation. Macro scale systems are usually deterministic. So in similarly, stochastic architecture, stochastic reconfiguration relies on units moving around using statistical processes. So here the exact location of the molecular module cannot be known. Whenever the module comes in contact with the body, then we can know the location. The exact location of each unit only known when it is connected to the main structure, but it may take an unknown path to move between locations. Whereas deterministic, at all times the location of the module is known, but whereas in stochastic, it is a statistically it moves. Whenever it comes in contact with the body or a rubber, only can be known the location of the molecule. Reconfiguration times can be guaranteed only statistically. Stochastic architectures are more favorable at micro scales.
Stochastic self-reconfiguration. Robots identical in form and intelligence randomly float about, assemble, and reconfigure. Modules assemble from a C unit. Using a simple instruction set, the unit activates certain body sites to form the desired structure. Units float dormant until they attach to the seed and receive power and instructions. Their only source of locomotion comes from the energy of their environment. Stochastic assembly and self-reconfiguration take advantage of many traits of the random system. A relatively high density of units increases the chances of a module finding at a desired position. Simple, homogeneous units leads to ease of manufacturing. The system exploits parallel construction. As it grows, increases numbers of bonding sites, speeds assembly. Clever intelligence algorithms ensure the structure is built in an order that yields the right efficiency. basic assembly provides an alternative means of instruction of deterministic methods. The need for careful, precise fabrication should place with a random system that forms structures over time. Today, macro models have 3D self-reconfiguration. Tomorrow, greater numbers at smaller scales.
Oh God. I'm sorry. So this sharing is stopped. Reconfigure modular robots motivation, chain architecture, mobile architecture, deterministic, stochastic. Okay. Modular robots also can be classified as homogeneous and heterogeneous. So in homogeneous, modular robot systems have many modules of the same design, forming a structure suitable to perform the required task. An advantage over other systems is that they are simple to scale in size by adding more units. A commonly described sharing contained by adding more units. A commonly described disadvantage is limits to functionality. The systems often require more modules to achieve a given function than heterogeneous system. So because the same modules are going to be manufactured, so the manufacturing cost is going to be reduced. But of course, the functionality when compared to the heterogeneous have some limitations, but homogeneous, the cost of the robot is going to be reduced a lot. Is an example for a homogeneous, the same units are going to be used for applications. So homogeneous. So same modules are going to be used here. In heterogeneous, different types of modules used. Because of that, so different activities so can be performed more easily when compared to the homogeneous. Heterogeneous robot system have different modules, each of which do specialized functions, forming a structure suitable to perform a task. And advantage is compactness and the versatility to design and add units to perform any task. A commonly described disadvantage is an increase in complexity of design, manufacturing, and the simulation method. So because the different types of modules has to be manufactured, because of that, in generally, the cost may be increased. I'm showing a very small video for this, but of course it is not a manufacturing method. So it is a small toy to understand heterogeneous system.
What are kids doing every day? Spending time on video games? Losing themselves in social media? What about him? Clickbot, a robot friend that can teach kids how to program. Clickbot takes old school building blocks to the next level by offering smart modules that allow kids to create cute and cool robots just in a click instant. Beck is sweet and sensitive. He can recognize you, then react to your touches and gestures. Beak is a self-balancing car who is full of energy and curious about everything. He could follow you as your smart puppy. They are two playmates that can accompany and play educational games together with your kids. With Clickbot, it's never limited to just these two characters. Crawling snakes, walking creatures, kids can create hundreds of robots by swapping out modules. Clickbot is simple to build and intelligible to program. The real-time 3D models in app help kids understand immediately what they've built. Via drag-and-drop graphic programming, our multiple sensors and actuators help kids easily bring their creations to life. Moreover, the process of trial and error can cultivate kids' logical thinking and strengthen their problem-solving skills. Kids can share their configurations to the community, where other users provide unique ideas and various contents. Now, let's see how Clickbot can surprise us. During their immersive creating time, kids are interested and entertained for hours. Our versatile Clickbot is never a disposable toy. It brings valuable time for both kids and parents by closely bonding family members. First time ever, education and play can be integrated so perfectly. It always requires time and patience to inspire kids' potential. But Clickbot has found a pleasant method to balance between hard work and enjoyment.
So now, other classifications, one more classification of reconfigurable robots are available. The reconfigurable system can also be classified according to the mechanism of reconfigurability, intra-reconfigurability, inter-reconfigurability, and nested reconfigurability. In intra-reconfigurability, robot system is a system that is a single entity while having ability to change morphology without the assembly or disassembly. Without assembly and disassembly, automatically they changes their molecules for the different positions. Then it is called intra reconfigurability. So whereas inter reconfigurability is defined as to what extent a robotic system can change its morphology through assembling or disassembling. By assembling and disassembling, if it can be changed to different positions, then it is inter reconfigurability. Whereas nested reconfigurability for robot system is a set of modular robots with individual reconfiguration or characteristics, so that combine with other homogeneous or heterogeneous robot modules, then it is nested reconfigurability. This is another way of classification. So later on we move on to reconfigurable model of robots. So number of robots are going to be developed by the different research institutes. So I will give you some of the examples of these robotic systems which are developed. So other one is a polybot. So polybot is going to be invented or produced or manufactured in 2002. Each module is about 50 mm on a side. Is a chain and self reconfigurable system. All the sides of the modules are constructed cubical in shape. It has one rotational degree of freedom. This type has many modes of locomotion such as walking, climbing, biped, legging, and snake, etc. This module has brushless flat motors with harmonic drive mechanism. So I will show how the polybot is going to be acts for different activities. So this is the figure which is developed. Later is a small video to understand the polybot. So the next one is molecules. So molecube system developed by Jaco et al. At Cornell University, built to physically demonstrate kinematic self-reproduction. Each module is a 0.65 kg cube with 100 mm long edges and one rotational degrees of freedom. The axis of rotation is aligned with the cube's longest diagonal. Physical self-reproduction of a 3 and 4 module robots was demonstrated, and theoretically existence of arbitrary sized replicating machines has been mathematically demonstrated. This molecules is going to be produced by the lab Cornell Computational Synthesis Lab in 2005. These are the molecules. So molecules which are going to be invented in the lab in 2005. So forms a robot. Okay. Superbot. The Superbot developed by Shen et al. At the University of Southern California as a deployable self-reconfigurable robot for a real-world applications outside laboratories. Its module have a hybrid chain and a lattice architecture. The modules have 3 degrees of freedom, so it contains a pitch, yaw, and rolling. So and can connect to each other through one of the 6 identical dock connectors. They can communicate and share power through their Docker connectors. For high level communication and control, the modules use a real time operating system. So here I am showing for each and every module very small videos to understand this. For this one, the rolling superboat has going to be shown to you. Maybe it is 1 minute or 1.5 minutes. This is the structure of with the structure which is invented by the superboat. So let next one is Michi robot. The Michi system developed by Rus et al. At MIT, Massachusetts Institute of Technology. So it is a modular lattice system capable of arbitrary shape formation. This system achieves self-assembly by disassembly and has demonstrated robust operation over hundreds of experiments. So each module is an autonomous robot cube capable of connecting to and communicating with its immediate neighbors. The modules use face-to-face communication communication implemented with an infrared system to detect the presence of neighbors. So when assembled into a structure, the modules from a system that can be visually sculpted using a computer interface and a distributed process. As a small model of this system is going to be shown in. So as discussed, so a lot of research is going on reconfigurable robots. So almost 30 systems are going to be developed in that. So 3 or 4 systems are given, for example, to understand the students or maybe the faculty members. So we can go through different modules to understand the remaining robots which are developed. But of course, so challenges in robots. So of course, we have seen what are the advantages or maybe the initiative, why we have to take the initiative to invent the or to go towards the reconfigurable robots. So maybe we have a lot of advantages, but even then there are a lot of challenges in robots. So, so even now today, so in spite of the above developments, a large number of humans are engaged in ground operations to carry out the missions like attacking terrorist camps. So we know that. So in Kashmir, so regularly our army or jawans are going to be killed by the terrorists. So even though this type of robots in future can be used, but of course they have a challenges to produce like that. Thwarting instructions in the border, tackling smugglers in the mid sea. These activities can result in heavy human casualties. To reduce the human casualties, so we can use this reconfigurable robots and future robots. But we have to develop the following. These are the qualities can be developed. So we have to come across the challenges to use these robots in future for the number of applications. The first one is so effective communication between the different modules as is given. However, the robot should possess the various capabilities that humans have. So humans have effective communication. So in similarly module to module, molecule to molecule, effective communication has to be increased. Intelligence, changing the posture, so depends upon the activities required. Ability to adjust the loss of member, because the number of small molecules are going to be used in a reconfigurable robot. So one molecule is going to be erratically behaved or maybe so damaged. So when it is loss of that module or a molecule, then it has to be adjusted immediately by itself to reduce workload of a manpower, to improve decision making. Then the robots are going to be in future will have a lot of applications in different areas. So challenges to be overcome in planning and control, challenges in locomotion, reconfigurable planning with and without obstacles. So there will have a lot of obstacles when compared to laboratory. So in actual practice, a lot of problems will be there. So if obstacle comes, so automatically it has to sense and it has to overcome the obstacle. Handling a variety of failure modes from misalignments and dead units and some erratically behaving molecules, determining the optimal configuration for a given task and environment. So different environments. So suppose we produce a rabo in a suppose 30 degrees temperature. When it is put into action in some 0 degrees or some other negative temperature. So suppose a rabo is going to be built in a research lab or some Hyderabad or maybe Bangalore, but later if it is put in a Kashmir, so then because of the temperature, the modules are not acted properly, then there will have a lot of problems. So depends upon the environment to withstand the environments and for sensing. So and also erratically, if any molecule is going to be behaved, that has to be eliminated itself, and other molecule has to be coming to that place, it has to act. So this type of planning challenges so will be there in reconfigurable manufacturing, reconfigurable robotic system. So other than that locomotive, so challenges in locomotion is a stability, because so rigidity is a major problem. So it's a small modules are going to be arranged, geometry and a number of contact points, center of gravity, static and dynamic stability, inclination of terrain. So if any area is going to be changes, so from hilly area and some area is going to be valleys, in that cases the terrain is going to be changed. So automatically the robot has to be adjust itself. Characteristics of contact of the points, path size, shape, and of course friction between the different modules, also a challenging task. So in planning and everything, so if all these obstacles if it is overcome in future, so the reconfigurable robots are going to be a trend, and different activities can be very easy. So whatever it may be, to attack in terrorists or maybe in working in minings or maybe undersea water operations, it will be have a lot of future and a lot of research is going on in this particular area. So now a lot of applications are available, but some of the applications, especially NASA program, space station repair, Mars exploration, moon station. So in underwater mining and planetary mining and like that. So in so many areas, the reconfigurable manufacturing can be can be used. Now I will show some of the applications to understand how these are going to be used. In particularly, we are already using the reconfigurable manufacturing in undersea under NASA programs. So one or two videos can be easy to understand these applications of the reconfigurable manufacturing. Oh, this is a space station. So one rabo. So if for particular application, suppose we are drilling, we want to use one rabo. For some other purpose, for handling some other, it's not possible. So for a space station, we have to send a number of robos. So because of that, I'm sorry, because of number of robos for one activity, one robo like that if you send. So if you want 50 activities, 50 robos is too costly to send the space. So in that case, one robo automatically changes itself can be performed. Number of activities will have a lot of advantage and cost consuming also and weight. So if you want to send a material or a item to the space, it is a too costly. So if one robo is going to be used, a reconfigurable robo can done all the activities, all the repairs of a space station we can imagine. So a lot of cost can be reduced in space. So it is a one application what I am going to you to understand underwater robot. So this is one more application for space application. So for NASA used this reconfigured robot. So for Mars. Okay. So we have one more application. Sorry.
Soft robot, by definition, is a robot made of things that are not rigid or not hard. We make robotic actuators out of rubber materials. No sensors, no tendons, no pulleys, no rigid joints. If you think about if you were going to build a robotic octopus, what would it look like? That was the inspiration for our technology.
Can you break down the technology on a really basic level as far as the inflation, how it actually works?
Great. So it basically, we take elastomeric material, so rubber, build a number of fluidic channels into it, layer it with composites, so other materials of other stiffness, and then by controlling the pressurization, the rate of pressurization, you get bending or extension or actuating. And so if you think about inflating a balloon, it inflates outwardly. With a soft robotic actuator, because you've built these layered composites and you've channeled the air in a certain way, you can get this gripping action. Instead of just an inflation, you get actuation.
And why is this better than a hard robotic hand?
Well, the best part is if you think about a traditional robot hand and you think about picking something up, it has to know exactly how to position. So it has to know the exact location of the object. It has to calculate its path. So there's a lot of numerical computation. And then there's sensors on those fingers. So it has to grasp that just enough, but not too much. So a lot of processing can be very slow, very tedious to solve this. What we've done is we've said, if you have a hand like a human hand, but it's made of rubber, it can just grab anything. And so that's what we do, is we use very simple vision systems. We do very little grasp planning, usually just aligning on the long axis to orient something in a package, and you just grab it. And one of the questions we always get asked is, how does the robot know that you've changed the objects? It doesn't know, and it doesn't need to know. All of the material science and the hand and the actuators allow it to conform to any object.
So it's a relatively new technology?
It is. It's been in the academic lab for some time. We actually spun out of George Whiteside's lab at Harvard. He started this work in 2008, 2009 under a DARPA contract. We started looking at it in 2012, and in 2013 we decided it was mature enough to really bring out, put into an entity with a focus on commercialization.
So now 5 years later, these are actually out in the world?
Started the company in July 2013, spent the first year trying to solve those two big problems, and really started selling late 2015. And these are out in the world in manufacturing environments today, everything from injection molding to assembling drinking cups to packaging bakery items.
Are these taking jobs away from people?
So what we're doing primarily in packaging is there's a labor shortage there. So we're working with customers in the food industry where they don't have enough people to staff their factories. And so it's not, how do I squeeze another bit of productivity out of my factory? It's how do I keep my factory running so I know I can supply product? And so a lot of these firms, they have temporary labor constantly coming and going. You think about training, the quality, all of those challenges. And so what we're looking to automate are things like packaging dough in a 40-degree warehouse. It's not a good job, it has high turnover. Or working in a high care area, or even some environments where people are packaging things in freezers. So you're in a -20 freezer hand packing. So not jobs that people want, addressing the acute labor shortage.
Okay. Friends, so we have discussed need of reconfigurable robots. What is reconfigurable robot? And later types of reconfigurable robot and history of reconfigurable robots and different architectures and some of the research robots which are manufactured in reconfigurable robots and some of the applications. So very few applications I have shown, but number of applications reconfigurable robot can be used. So self-reconfigurable robotic systems are potentially more robust and more adaptive than conventional system. So conventional system for applications are going to be limited. So whereas reconfigurable manufacturing reconfigurable robots, so any activity so it automatically changes itself with its molecules and modules. So and it is ready for the different applications applications. The reconfiguration ability allows a robot or a group of robots to disassemble and reassemble machines to form new morphologies that are better suitable for new tasks, such as changing from legged robot to snake robot and then to a rolling robot. So I have shown some of the videos how the reconfigurable robot will act itself to change for conventional position. So depends upon the activity it requires. Self-reconfiguring robotic system can potentially lower overall robot cost by making a range of complex machines out of a single type of mass production modules. So in reconfigurable manufacturing system, so a single module or maybe in heterogeneous, a very few number of, so 3 or 4 type of modules only manufactured, because one module is going to be copied a number of times, and the production cost is going to be reduces a lot. So production cost is reduces, and any activity the robo is ready and the degrees of freedom is more. So reconfigurable robots are going to be a trend in future manufacturing. So now what my idea is, so is to throw light for further research the students who are attending for this workshop and faculty members who want to go research. So a lot of scope is available in reconfigurable robots or reconfigurable manufacturing system. Lot of research institutions are working so towards in this area, and a lot of that means machines or robots are going to be produced in this area. You have a lot of scope and space to work. Any queries, please? Hello.
Hello, dear participants, is there any queries?
Any queries? No queries? Okay.
Establish a colony on the moon. Off-World has a bold vision to build self-replicating robots which are based on machine learning. These machines can theoretically mine more fuel and begin modular construction on the moon's surface, streamlining
I'm showing one
unworkable
more
habitat
application.
for humans. It would be a vital step towards space colonization. But there are endless applications for swarm robotics, and there really is no limit to this type of technology. So without further ado, let's begin the top 7 countdown. Beginning at number 7, the Kilobot. One of the first pioneers to swarm robotics is the Kilobot. They are the first group of robotics to feature an algorithm which allows the units to self-assemble and heal a collective shape. The Kilobots are pretty simple in themselves, and they can move around using vibration. Each robot is equipped with an infrared transmitter and receiver, and this allows them to perform the collective algorithm. This collective system would probably not take over the world and destroy us all, but it does show that the most simplistic robots can work together and even form complex shapes. We get to number 6, and it's the Smarticle. Contrary to its name, this robot is physically as simplistic as you can get. Each unit has 2 arms and literally cannot move anywhere, sort of like flapping your arms to the water with no sense of coordination. But this is where it gets intriguing, since multiple robots inside a ring can actually move the entire contraption. And with a photo sensor, one robot can be deactivated, and the Smarticle can move in a specific direction. Now that may seem a little bit boring, but these simplistic yet controllable robots can be scaled down. And with an additional algorithm, we may see thousands of similar microrobots being able to do even more complex tasks. We get to number 5, and contrary to its name, it's called the particle robot. One of the most important keys to swarm robotics is the ability to collectively explore, communicate, and perform complex alterations as a group. The particle robot is a step towards unified abilities, and they can work together to move objects and form larger structures. They are a pretty ingenious design since they can only move by contracting and expanding. But they are able to move towards a light source, and they can actually sense each other physically, so they don't actually directly communicate with each other. So think of the particle robot as more of a reactive machine, where it can move around on its own, but it will react to its environment. Now, I personally think this is a really important aspect to microrobotics because you do need something which can sense its own environment. But at the same time, we also need a machine which has an algorithm to perform complex tasks. Nevertheless, the particle robot is a very interesting project to follow. Now we reach number 4, and it's a little bit unconventional, and it's called the Tribot. I always find unconventional robotics intriguing, and these things basically move around using two-shaped memory actuators. They are actually modeled after a trapjaw ant, which is a bizarre creature that can bite the ground and launch itself straight into the air. That just sounds crazy in itself. So why are these things so impressive? Well, with a leader, messenger, and other workers, they can collectively move things, sort of like your boss telling you what to do at your job. Fortunately, these robots are quite obedient, and there won't be any worker strikes anytime soon. We get to number 3, and it's the relative robot. Built from the pursuit of programmable matter, these collaborative robots build complex structures from small identical pieces. They are unique in the fact that they don't require any sophisticated navigation equipment. The assembler robot is sort of like a part of the structure in itself, and they actually use a thing called voxels. So every time the robot takes on a step or moves into a different position, it would already know the voxel it's on, and therefore it would continue the construction of the object. This ultimately means that these assemblers can build very large structures, and maybe even one day build off-world habitats. We get to number 2, and it's the M block. Yet another step towards programmable matter plays around with self-assembling cubes. Each cube has a built-in flywheel to move around, and small magnets to clip onto each other. The collective communicates by using a barcode system, which allows the units to identify each other, and therefore move in coordination. The result is a swarm which can follow arrows, track light, and even build simplistic structures. Although it would be neat to see them actually form a Rubik's Cube. I would definitely buy this if it was on the open market, but for now it's still in a research phase at the MIT University. Now at the great number 1, the S'mores EP. Once again, the Mod Lab has made some unique, self-configurable modular robots which can transform into bigger machines. Each module has a docking station with a built-in reconfiguration algorithm, so they can change variations including a walker all the way to a basic vehicle with an arm. And they are kind of like Transformers when I think about it. Now they may seem a little bit slow and basic, but imagine thousands of these units at a smaller scale. Maybe even nanoscale. They would be able to transform into pretty much anything, and there really is no limit to this type of technology. So once again, thanks for watching. Please like the video if you found it useful or enjoyable, and make sure to subscribe to my channel.
These robots can configure themselves to make, move, or enhance furniture. They're called Roombots, and they're made by the Swiss Federal Institute of Technology Lausanne, or EPFL for short. These autonomous, rollable, stackable robotic orbs can lock onto each other to form a variety of shapes and perform a variety of functions. They're still in the proof of concept stage of development, but the possibilities are literally limitless. A recent video released by the EPFL shows the robots autonomously assembling into a chair, with an occasional human assist to nudge them into position or change batteries. Think about the potential here, especially for folks with limited living space. Someday, instead of awkwardly pulling a chair out of storage when you've got company, you could just call on your Roombots to make an extra chair for you right there on the spot. They could probably make moving a whole lot easier too. The Roombots also can light up in case you need help finding them in the dark, or you just want some modular furniture that can turn up. Another potential use of these Roombots is that they can help modify and enhance existing furniture. For example, you could enable a table to pick a pen off the floor and keep itself level over slopes and stairs. When it comes to chairs, Roombots can push one around by rolling on the ground to follow you or stay out of your hair. For some of these experiments, the Roombots worked in conjunction with a Microsoft Kinect camera, enabling the robots to move in reaction to the movements of a person. These Roombots aren't the only modular robots currently in development. MIT's MBlocks 2.0 connect to each other using magnets and use a barcode type system to identify one another. Inside the blocks is a flywheel capable of 20,000 rotations per minute. When a brake is applied to the flywheel, it creates the momentum that moves the block. While these modular robots don't yet appear to be as dexterous as some other robots which were designed to perform specific tasks, the appeal of modular robots is that they could be deployed in cases where the exact type of robotic assistance required is hard to predict. For example, the MIT engineers behind the MBlocks envision them potentially being used to aid in disaster response, perhaps being put to work rebuilding a part of a staircase that was damaged, where rescue workers could have easier access. Similarly, the EPFL envisions the Roombots might be a space saver in small apartments, or a way to enhance furniture to assist people with limited mobility. In addition to their potential earthly uses, modular robots could also play an important role in building a future for humans in space. In a NASA contest aimed at designing a home for astronauts on Mars, architecture firm Hassel envisioned modular robots arriving long before the first astronauts to get a head start on building a base camp. Of course, modular robots with these types of capabilities are years, if not decades away. But these early prototypes certainly prove that, like the humans that created them, these modular robots can accomplish a whole lot more when they work together. What would you do with your very own form of modular robots? Let us know down below. For more of the latest future tech news, check out these videos. As always, thanks so much for watching. I'm your host, Jesse Orrell. Stay safe out there, everybody.
Good morning, sir.
Good morning.
Sir, I am Mr. Houmin Shen, Assistant Professor, EC Department of Asansol Engineering College. Sir, I request to you that please you give us this video link of
modular robots.
Video link of.
Sir.
Sir, I request to you that please give us a video link of all these projects or applications.
Surely. I will send all of this to the Narayana Engineering College Mechanical Department. Surely you can use all of this for your work, please.
So, okay, sir. Thank you, sir.
Thank you,
sir.
Hello.
Hello, sir.
1 minute, amma. Mallekada miss ayipoyina nenu.
Okay.
I am sorry. Any queries, please? I'm 5 minutes left. Or otherwise, I will show one more application. So a lot of applications are there. I hope time is less because of the only 3 applications. So later on, I showed one more application. Number of applications, number of videos are available. I will send to the organizers. Sure, any student or faculty can use for their work. Anything, please. So for interactive session, so only 5 minutes are left. Or otherwise, I will put a small video for the remaining 2 or 3 minutes. Then maybe the session may be end. Sridhar sir? Sridhar sir, Unarama?
Yes, sir.
Okay. 50 members are there. So attending, but no one is putting any queries because so it is an advanced area.
Sir,
please.
Sir, this type of technology you are expanding to the agriculture field. So in the agriculture field is very, very useful for this type of technology, sir. Please
surely. Yes.
I think it is very useful to the agriculture field, sir.
Yes, yes, sir. So in any field, it is very much useful place. So is in a terrorist attacks. So in future, we can use this type of robots. So now, so many soldiers are going to be killed by the terrorists. So we can use this technology to save our soldiers at the borders. So because at Siachen, so below 70 degrees, minus 70 degrees, our soldiers has to live. It is most difficult at that places. We can use our reconfigurable robots for the terrorists, so not to come into in our territory. So these are very much useful, sir, in seas, sorry, in mining. So mining, so because we have to go in deep and work, so in underground areas, so for human being it is very difficult to survive. So this robots, so we can use it for our requirement. Surely a lot of applications are available, sir, but it is not possible to show all the applications which are I'm having. So because of that, I have shown only one or two applications. So I hope this time is sufficient, but it's only 2 or 3 minutes left. Because of that, I have shown only two videos, but number of applications are available with me. So any queries, please, other than this? Madam?
Hello, sir.
చెప్పండి మేడం. ఓన్లీ 2 minutes అనుకుంటా, నాకు తెలియదు మరి టైమింగ్ మీరే చెప్పాలి. హౌ మచ్ టైమ్ ఇస్ లెఫ్ట్ టు మీ?
Okay, sir. You can conclude this one, sir.
Okay. Thank you very much, madam.
Thank you very much,
So
sir.
for giving me the chance to interact with so many people, I am very happy and I am very thankful to the organizers. So for giving me the opportunity to interact with so many experts which are there on the online. So thank you very much. Thank you, madam.
The informative session.
Sir, one of the student is there, sir, at your Srinivas College, I think Kornulu. Fakruddin, sir. Fakruddin is there, sir.
Fakruddin is.
Yes. Now he was working in CMR Engineering College, sir.
Okay.
Yes,
He's a very nice student. Fakruddin is a short fellow.
Yes, sir. Yes, sir.
Sir, good morning, sir.
Good morning. Good morning. Fakruddin is there?
Yes, sir. Yes, sir.
Fakruddin గుర్తుపడతా నేను.
Yes, sir. Yes, sir. I am here, sir.
First batch student na Rakesh.
Yes, sir. Yes, sir.
Okay. Okay.
So thank you, sir. Thank you for your speech, sir.
Thank you very much. So
Okay, sir. Thank you. Thank you, sir.
So thank you for the information about the
madam.
reconfigurable robots.
Madam.
Thank you very much, sir. Okay, sir.
Thank you, madam.
Dear participants, you may log in at 11:30. The next session is on medical applications of robots by GL Samuel, sir, professor from IIT Madras. Okay, sir, you may log in at 11:30. Thank you.
Sir, good morning, sir. Hello. So, Dr. Samuel, sir. Hello. Hello. Hello, sir. Hello. Madam. Hello.
Hello, sir.
Sir, good morning, sir. Hello. Hello, sir. Hello. Good morning, sir. Dr. Samuel, sir.
Hello, sir. Sir, login అయ్యారు సార్. పోస్ట్ ఇచ్చాను సార్. పోస్ట్ ఇచ్చాను సార్. మీరు అన్మ్యూట్ చేసుకుంటే మాట్లాడుతున్నారు సార్. ఓకే సార్.
Hello. Sir, Dr. Samuel, sir. Sir, welcome, sir.
సార్ అన్మ్యూట్ అవ్వలేదు సార్. చెప్పండి.
Hello.
Good morning, sir.
Sir, good morning, sir. Sir, is it okay, sir? Sir, welcome, sir. Hello.
Sir, good morning.
Sir, very good morning, sir. Yes, good morning, Dr. G.L. Samuel, sir, and all participants for today's second session on applications of medical applications of robots. Very happy to invite you, sir, again to this faculty development program on robotics.
Thank you, sir.
In association with Aicte, Atal, and as well as Narayana Engineering College, Nellore, Department of Mechanical Engineering, sir. Sir, you all know very well that sir already talked about introduction to robotics as a first session on 14th December from 9:45 to 11:15. Okay. Again, I am warm welcome to sir for today's session also. Already I introduced sir on 14th December as a chief guest and a resource person. Again, I am going to give some very brief introduction about sir for some other participants. Sir, Dr. G.L. Samuel, sir, working as a professor in Mechanical Engineering Department, IIT Chennai. Sir, awarded with postdoctoral fellow from National University, South Korea, and also awarded with PhD from Indian Institute of Technology, Madras, and a master's degree with BDT College of Engineering, Karnataka, and BE degree with the same college, Karnataka. And sir also worked with sir is having nearly 20 plus years of experience in research as well as institute as a faculty in various positions in various institutions. And Sir have received various awards, and also Sir is involved in so many administrative activities, acting as an advisor for PWD and weaker section IIT Madras, and member board of infrastructure IIT Madras, and also member board of studies IIT Madras, and member placement IIT Madras, and head of the laboratory manufacturing engineering section. Sir is a life member in MISTE and also Institute of Engineers, Australian Institute of Higher Energetic Materials, and also as a member, executive member in Fluid Power Society of India, treasurer in Single Point Diamond Tool Society. And Sir has published a number of papers in national, international journals, and also attended so many conferences, and also reviewer for various books, tool design book, and also machine drawing book, and guest editor for International Journal of Precision Technology, special issue on advances in precision and micro manufacturing. With this brief introduction, I am again inviting you, sir, to this faculty development program for last session. So fortunately, sir started first section and also concluded with the last session, sir. Thank you so much, sir, on behalf of our college as well as AICT Atal, sir. Thank you so much, sir.
Okay, thank you, sir. Thank you for that introduction. So I think all the participants, you can see the screen, isn't it?
Yes, sir.
So in the last session also I told, so I'll be interactive and asking questions. So please answer them quickly so that we can move forward. So hope you had a very useful week listening to eminent people from various institutions and industry, talking about robotics, their application, so kinematics, inverse kinematics, and all these aspects. So we have also looked at some of the industrial applications of robots while looking at the introduction of robots. So today we are specifically looking at the medical application of robots, but in my lecture, so I would also like to give you some information about the technologies which enable the manufacture of such kind of robots and other applications. Okay, as we have defined in the last class, a very formal kind of a definition we are given, where we defined robot as a manipulator which can move and all those kind of things. But if you really look at robot from that level, so now it has come to a very advanced level. So once we tell robots, we don't just imagine it as a manipulator which is programmable, and that is mostly applicable to something like a pick and place kind of a robot. So it is not that. Nowadays we have such a kind of an advanced robots that if something which can act similar to the human being, so we look at them as robots. So from that level of just a manipulator doing some of the repetitive works, so we have grown into the level. So today we are going to see some of the videos which will give us a better knowledge how robots have been practically working specifically today in the area of medical applications. So the robots, sensors are very, very important. I hope you have studied about some of the sensors which are being used in the robots. Can you name some of the sensors which are used in robots? Yeah, can some names? Sunil Kumar, you are there? Yeah, Kirtika, or anybody can answer. So what are the different types of sensors which are generally used in robots?
Proximity sensors.
Very good. Proximity sensor. Yeah.
IR sensor.
IR sensors.
Ultrasonic sensors.
Ultrasonic sensors. Yeah. Still, one thing which is also very popular, I also mentioned in my previous lecture. Yeah, tactile or tactile, you call some people, but it is tactile or touch sensors. So, which are very important. So, if you look at the sensors, what the engineers we have developed are similar to what the sensors, sensory organs, what we have in the human beings. So, AI, artificial intelligence, robots, and many of these technologies what have been developed these days are actually there in the nature. I'm also today going to show you some examples of that. So does humans have 5 sensors? Can someone say which are those 5? Yeah. You can unmute and say which are the 5 sensors humans have. Kiran Kumar, Sunil Kumar, Radha, Sunny Kumar. You're all there. Others also can say. So I just
Hearing for hearing purpose, for
hearing,
observing, as well
yeah,
as for touching, as well
touch,
as smell.
Smell, yeah.
And
Vision.
taste.
Yeah, taste, vision.
Yeah.
Very, very important. So there are sensors actually to smell. So there were, I have also actually seen the development of these sensors, what are called as the artificial nose, because whenever there is a leak in a factory, or if there is any leak, even in domestic, sometimes when the gas leaks, so we can keep the sensors which can give an alarm. So like the smoke detectors, we can also put these sensors. So we can put the artificial nose so that it can detect. And in some of the chemical factories, they have even the capability to detect which gas has leaked or what is causing the smell. So thus nose, artificial nose, smell is another important one. Taste, though there are some of the sensors which have been developed in food industry, but they are not that popular like what we have. The touch sensor, the vision sensors, which are the most popular one are the vision sensors. So touch sensor, smell, so all the 5 sensors, whatever human beings has, so they have been used on the robots. So if you look at the application of robots in the medical field, so almost whatever the activities what are being done in an hospital are being assisted by the robots. And actually, when I was discussing with some of the doctors, when we are trying to do some work for medical applications, I was surprised. See, we are engineers. I think most of you are here are engineers, and we develop the technology. And do you know which is the field that applies most of our technology right as early as possible? That is nothing but the medical field. So when I'll be talking about micro machining by using a small tools, and I'll also be asking some questions about that. So when we were trying to get the spindles which can use the small tools, we were looking for a spindle. So in engineering and in industry, we couldn't get the spindle. But finally, we went actually to a dentist and we could get a machine actually, which they were using it basically for drilling the tooth. But then we put our tools and tried to machine it, but the cutting force are much higher in metal cutting we couldn't do, but then later we contacted some of the German and US companies, and we could get the spindle which can machine the metals. It's called as a micro machining by using the traditional or the cutting tools. So thus we were surprised to find that most of the technologies what we are talking about by engineers are applied immediately to the medical field, and then they have changed the whole medical field. Now if you go to an hospital, it looks more technologically advanced than when you walk into an industry. Will you agree with this? Yeah, any answer, yes or no?
Yes, sir.
Yeah. So when you walk into an hospital, we see that most of the technology is put to practice there rather than even in an industry. So there's many areas so where the diagnostic, surgery, rehabilitation, so doing some of the procedures, surgical procedures and other procedures, then treatment, pre-treatment, post-treatment, and all, in all these things, then even simulation. So the medical simulations and the medical analysis are much advanced than the analysis what we do. So we were actually discussing about the, what do you call as pattern recognition. So then we said, as a mechanical engineers, we use vision systems now in identifying the parts, so which will have the circular shape or triangular shape or rectangular shape. So these are which are basic pattern recognition. But you know how advanced the medical people are in analyzing that kind of a graphical, 3D graphical data. So nowadays, if you go to any hospital, when they take the CT scan, even before doctor comes or looks at that particular CT scan, the computer itself will tell what is the problem. Is it normal or is there any problem there? You know how they does that? So it uses that large amount of data which has been generated and then puts all of them together into a 3D data and then compares it with the normal organ. Like for example, if it is a heart with a normal heart, or if it is a brain, it compares with the brain and then quickly tells what is the problem or there is no problem. Then actually the medical doctor will come and also look at it carefully. And if the computer has pointed out something, they will look at it more carefully. And then most of the time they find that whatever the computer has shown, that is right. In some cases, okay, now that may be some error or something like that. But most of the time, whatever the computer indicates, so the doctors will be careful enough to look at that particular part more carefully and see whether it is right or not. So thus modeling and simulation and even an analysis part. So the medical field has used our engineering techniques to the maximum extent, even in guiding the doctors, even caring for the patients. So in our lecture, we are going to look at them. So before we go into the medical area, so we have been working in this area, what is called as a micro manufacturing. So micro manufacturing. If you look at some of the engineering products, so there are several products which have been developed by engineers, and some of them are being used in the medical field. So here you can see one example. So the one what you see here is mini petrol engine. So where you can fill few drops of petrol into this engine and it can run for years. So in US, when they were trying to develop the batteries, so usually in the batteries which come in the watches and all, even in quartz watches, so the life is like 1 year, 1.5 years, or 2 years. So every time we need to change the battery. But now if you have this kind of an mini petrol engine, we can run the watch for almost 10 years with few drops of petrol. So that is how actually they tried and then made at the laboratory level. Then other products, we can see the cameras, tiny cameras coming in all sizes and shapes. So even on a pen cap, you can just have a camera. So that does, you can have a very small cameras, micro shafts, micro needles, so micro pumps, and all these kind of a parts, we can make it by what is called as micro manufacturing. So thus nowadays we see so many micro and even nano products. I think, hope you understand what is the practical size of micro and nano. Can somebody give an example to make a person who is a non-engineer to understand what is a micrometer? So did you understand my question? So think that you are doing a lot of research and then somebody comes and asks, maybe from your village, and ask, what is a micrometer? So how do you tell them so that they can understand? Yeah, any quick answer? Yeah.
Yeah, take a size of a hair.
Pardon?
Size of a hair.
Size of a hair. Okay. How much is the size of hair? Diameter?
Sorry, it's nano.
It will be? Yeah. What is the size of the hair? Yeah, please go ahead. Somebody was telling something, but yeah, anyone else? Hemant Kumar, you're trying to say something? Yeah, how do you tell them to understand what is 1 micrometer? Jisha, Varghese, M. Ravi Kumar, Murugeshan. Yeah, please go ahead. Yeah, how do you define a micrometer? Somebody is speaking, I'm not able to hear. Kalari Timmana? Yeah, can you answer what is a micrometer? Okay, what? Timmappa, sorry. Tamil Nation.
10 power minus 6.
Yeah, 10 to the power minus 6, that is fine. But how do you make others to understand, those who doesn't know the numbers like this? Okay, fine. So to save the time, we'll go ahead. So micro nano products are the products which have the 3D structures and which have the moving parts with the dimensions and features in the range of micro and nanometers. So thus making them to small size is very, very important, and it is not as easy as you think. So sometimes we just write like 10 micrometers, 100 micrometers, but go practically to a shop floor and then try to achieve that tolerances or that dimensions. It is a very big challenge. But these kind of a trends have been happening. It is called as miniaturization. So where earlier the products were very big, but nowadays with the micro manufacturing technologies, we are able to make them to a small scale. So good examples for these kind of a miniaturization is like our computers, our cell phones. So the first computers were so huge that they were like a big room, but now with the help of these miniaturization technologies, they have been made very, very small, portable, and very powerful. So these are the trends which have been happening. And you know what is the inspiration for these kind of inventions and to go forward in making these smaller components is the nature. So it looks like there is a vase, which is a small insect, what you see here. So that vase has a zinc-tipped tail. So it will be something like the tail, and the tip is made with zinc, and it will be able to drill the holes very, very small diameter in the wood or the trunk of the tree. So, and when the scientists actually observed it, they found that the tail will be like very flexible, but whenever it want to drill the hole, so it will pump in the fluid and it becomes stiff. So once it has become stiff, it starts rotating the tip at a very high frequency. So it is something like a vibration plus a kind of a rotary motion. So then there'll be a small zinc tip and then it starts drilling. And whenever the hardness of the wood is higher, and if the zinc is about to break, you know what happens? The zinc tip will not break, but actually the tail will just bend like this. So that means before the tip breaks, the tail actually bends and then releases the forces. So thus, during the lifetime of that vase, never the tip breaks, even when it is trying to drill the hard material. But actually to achieve this kind of a technology in micro machining, even after so much of research, so we still find it difficult. So we have small tools which are of the order of 50 micrometers, 40 micrometers, which are smaller diameter than the hair. So many times when you make a mistake, even before it starts machining, they break. But for this one, the tip never breaks because they have that kind of a flexible tail. But we try to introduce that in engineering. Still, there are several challenges. So you need a flexible kind of a shaft, so where you can limit the load and still achieve the torque which is required to drill the metals. But that technology is still a challenge. So thus nature has. And also like another inspiration, so we talk about what is called as a micro gears these days. So where we have small gates and we can transmit the power through that kind of a gears. But you know, in nature, so this is there in the Scientific American Journal, that video is there. So there is no provision to download that. So probably you can use this link or put this title. So mechanical gears in nature, if you put like that, the website will come, or you can use this address. You can see the video, how the small insects has a gear kind of a structure in the hind legs, that is the behind legs, and it locks these legs before it makes the jump. Okay, so thus, though it is a small insect, but it can jump longer distance because of these kind of gear technology. So they were all there in the nature, and even many of the medical robots, what we see, they're all being inspired by the human. So thus in the creation, so there are all these secrets and we are trying only to implement them. And of course, artificial intelligence is nothing but mimicking the cognitive capacity what the human beings has. Okay, then if you look at the technology, I hope most of you are mechanical engineers and you can understand these things. So generally these topics, each of them, if you take, it takes several hours to complete, but I just try to put these technologies in a slide. So like mechanical micro machining, so where we can use the physical tools. I'll show you some of the SEM images. So probably, okay, sorry, you can understand here. So these are like few micrometer tools. These are all SEM images with what is the magnification? So something like 500 times 180 times 183K. So that is the order of magnification with which you are seeing these things. So they are actually the cutting edges because it is magnified. So for us, it looks like blunt, but they are the cutting edges. So thus we can use that small mechanical components, mechanical tools, and we can manufacture the micro products. Then focused ion beam. So you can remove atom by atom the material and you can make the shapes like nano pillars, nano cones and structures. Then lasers are one which are being very popularly used. Actually, we have a laser here at IIT Madras under a project, what is called as a femtosecond laser. So they come under what is called as ultra short pulsed lasers. So they are very powerful. We are actually trying to machine titanium, Inconel and other types of difficult to machine material. But these lasers are so powerful, you put a pulse of laser on that, that material, even though it is a difficult to machine material and high temperature material, that means its melting point is around 1500 and above, but it doesn't even melt, but just evaporates when you put a pulse of this kind of femtosecond laser on that surface of the metal. So that powerful they are. So lasers are very popularly used. Then we have EDM, electromechanical, electrical discharge machining. Then we have chemical machining, ultrasonic machining. So then some of the lithographic kind of techniques. So they all come under what is called as MEMS technologies, micro electromechanical systems. So under that technologies, we can manufacture. So thus there are several technologies these days, even 3D printing. So they started printing the micro and nano components these days. So thus we have several technologies by using which we can make the micro products. So because of these kind of a products only, we are able to make and change the whole medical field. So some of the examples I'll give, and then later we'll be talking about the medical robots. So earlier, when we were children, so whenever we make noise in the class or even in house, so the teacher or parents used to threaten. So if you make noise, we are going to put injection. Why? That is the most painful experience every child probably would have gone through. So when you say we'll put injection, they'll sit silently. They're afraid of it. So that's how it is. But nowadays, we have what is called as painless injections. How is it possible? Mosquito is the good example. You know, when mosquito is biting us and when it is sucking the blood, we'll never notice. And sometimes we'll feel the itch. You know, that is not because of the bite of the sting, but that is basically due to the chemicals which it releases. Okay, so thus why it is painless? Because the diameter of the sting is very, very small, so we can't even feel the pain. So thus even if injection sizes, diameters are made small, then it will be painless. So nowadays it is possible actually to make these kind of a micro needles. So thus injection process have become very much painless. Then you would have heard about the laparoscopy surgeries. So it is called minimal so insertion. So you don't have to cut much. So only a small portion will be cut in the body. Then all these devices, so like a camera, then depending on the surgery, it need to carry something like, yeah. Anything else? Somebody want to say something? Okay, so different devices can be sent inside, then the surgery can be carried out, then these instruments will be withdrawn. Then nowadays we have actually what is called as a pinhole surgery. So where you can just make a small hole. So what you are seeing here, as small as this, and then by using that, so the small pinhole there, and using that we can carry out the surgeries. So these are all possible because of miniaturization. So there are products actually what is called as blood filters. So we bought actually one machine to make the micro machining by using the conventional tools, and the name of that company was Kern from Germany. So when we were purchasing that machine, so the engineer from that came and demonstrated these things. So these were called as the blood filters. So wherein you can put these things across the arteries which are leading the veins which are leading the blood into the heart, and we can allow regular blood cells to pass through these holes, but stop the fat so that it's not going to go inside the heart and damage the heart. So these are all possible when you can make these holes exactly to the required size, where it need to allow like RBCs, WBCs and regular blood cells, and stop the fat particles which are generally will be agglomerated. That means they stick together and they'll be larger in size. Okay, then this is called as a lab on a chip. So why it is called lab on a chip is when you go to the blood test, so generally they take one tube of blood, test tube of blood, and then they carry out only one test. But here, by putting few drops of blood here, so we can carry out different tests in each of these chambers. So that is the reason it is called as a lab on a chip, and the size of it will be something like an ID card. So the right side one, what you see, so this is what we actually machine by using our facilities here in IIT Madras. So thus we can make a small kind of a chips. You can look at the size of these things. So we can make 0.6, that is 600 micrometer size, and even you can make a smaller them. So these are the cutting tools which already I have shown. And we can actually talk about laser and other methods, how we can manufacture the components by using these technologies. So if you are interested, you can look at some of my papers on EDM and laser, and also in the cutting tools, so where we have been using these technologies for making the features. So rather than making the products, so we have been looking at the technology side of it. Okay, now coming back to our medical robots. Yeah, in the meantime, is there any doubts or questions? Any doubts or questions? Just 1 minute, I'll take a break. Yeah, you can tell, keep answering it. Any questions or doubts? Even during the lecture, you can ask if you have any questions. Or now also you can ask. Any questions? Okay, so if you don't have any questions, we'll go forward. So these are some of the robots which have been practically put to use, and they have been working in the medical field. So we'll look at them one by one. So in 2000 itself, So this robot has come. The name of it is DAY5. So each of these robots actually work in different fields. So thus we have taken the examples, one robot and one function. So now this is actually a robot which can help in what is called as minimally invasive approach. Okay, so even when I was trying to tell about the laparoscopic surgery, so this is what it is called, minimal invasive approach. That means the cut will be very small, but the whatever you want to carry out, so that function is done. So earlier, if you want to remove probably a kidney stone or something like that, we need to make a big cut, 7 stitches, 8 stitches we need to put and then remove the stone. But nowadays, just a small 1 stitch, or even for pinhole surgery, you don't even need that stitch. The skin itself will just close. That small, we can have small incision and insert all the instruments inside and carry out the surgery whatever you want. So that is called as the minimally invasive approach. And this robot has been working, though actually there were some issues. So there were some mistakes which are made by the robot. So that is the reason always it will be watched by the surgeons. So we don't leave the patient into the hands of robot. So the medical doctors will be there, they'll be looking at it, and if at all they feel something is going wrong, immediately they will intervene and then correct that. So here you can see the video where the robot is carrying out the surgery. Can you hear the sound?
Yes, sir.
So robotic arms remotely controlled. You can put whatever the device we need. If you want to cut, you can put a rotary kind of a tool there. And it is controlled by the surgeon. It is inside the human body. So this is outside actually. So the same procedure is being carried out inside. They can control the movement of the robot by using the hand movements outside. It is putting the suture there inside the body. Yeah, so then the next one, it is called actuated and sensory prosthesis. So probably you'd have heard this term. So where when legs or hands are amputated, so they fix the artificial leg limbs. So it is called limbs. So prosthesis, they are called as, and then the human being can carry out the work not exactly like hand, but almost similar to what the regular hand functions. And nowadays, people have been studying the brain activities and they are trying to convert the brain signals into physical activity. Now, for example, so in the brain, if I say, okay, lift my hand. So when we have God-given hand, we generally do that. But if it is a prosthesis, they need to put a lot of effort and do that. But now if we can connect the signals, so even without effort, when you tell mentally lift this, so it will be actually lifted. So still kind of research is going on, but here like a physiotherapy, and after practice, so they try and then to be as normal as possible. So on the top side, what the video you can see is he's practicing with that prosthesis, artificial limb hand, and then later he will try to hold the things. They will get adopted. They may not be able to hold like our normal hand, but still they'll be able to carry out many of the functions. Then in the bottom side, you can see the prosthesis legs, so artificial legs. So many times I think when we were children, we used to read about the stories about people going into a war, losing their legs, and when they come back, they have to spend the whole time on a bed or in a wheelchair and all. But nowadays, it's not like that. They can actually fix these kind of limbs and try to live mostly the normal kind of a life. So MIT Biomechatronics, Massachusetts Institute of Technology in US, so their biomechatronics lab, so they have developed some of these kind of actuator and prosthesis which can help in human beings. So even in IIT, this kind of a work is going on. Probably you would have seen in some of the news, so where a standing wheelchair which helps the people to get up more easily, and there are some videos you can search for that in the Google. So you can put standing wheelchair IIT Madras. If you put, you can get some of the things which have been done here at IIT Madras. Okay, then endoscopy boat, robot. So boat means robot. So usually, if any of your family members would have gone through this, you will understand how painful this endoscopy procedure is. Actually, whenever there is a problem with the colon or the intestine or in the stomach, abdomen, so what they do is they take a camera, which is a very big size, and then they insert it through the throat, and then it goes inside the stomach, and then it looks around, and we can see inside the stomach on a screen. And this camera used to be a bigger size, and they used to put a jelly inside the mouth, and then they'll push it so that it can go very smooth. And patients are more afraid of this procedure rather than even the surgery. Surgery is because they give anesthesia and you don't have to, you'll not know much. But this is more done like a live, and it's a very painful process. So that's what I heard from the people who has undergone. But now we have actually what is called as an endoscopy capsule. So it will be something like a size of a capsule, which the patient can swallow. Then it will have the cameras, tiny cameras. It will go inside, and then we can see whatever regularly what we want to see inside the abdomen or the intestines. And finally, it will come out. So thus, it is a very, very simple process and less painful. So that is possible because we're able to manufacture and make those minute or mini cameras and all the devices, transmitters, everything has been packed into this capsule size module, and we can send it inside the human body. Then orthosis, so this is another type of mobility, helping the people to walk and teach them. So you can see here, so we can help them. So those who have orthosis, so it is a type of weakness, so where they cannot do the regular works, but we can give the help of the robot. You can see here, and they can practice and try to live a normal kind of a life. Then targeted therapy is another very advanced kind of technology which has been introduced in the medical field. So what is targeted therapy means? See, for example, if there is a cancer tissue or a tumor somewhere inside the stomach, you give actually injection, that is chemicals, then it goes into the whole body, and some part actually reaches that particular tumor, targets it, but at the same time it goes through the whole body, and then the whole body gets affected. Probably you might have seen some of the cancer patients who have been suffering because of these kind of treatment. So, but instead of that, actually, what we can do is we can deliver the drug exactly in the place where the tumor is there. So in that case, the tissue or the body in the other places need not be damaged. We can deliver it only to that particular spot. And how we can do that is, again, we can make a micro kind of the capsule where you can put the drug inside, then you can send it into the body. So it will go and attach it only to the place where there is a tumor. So I think based on the chemical affinity and other characteristics, so you can make them. So once it gets attached to it, it starts releasing the medicine slowly. So thus, it's actually possible. So even in diabetic patients, slowly to release the medicine, they use these kind of technologies. So they wear a small micro needle strip. So then usually what happens is whenever they eat the food, the insulin level shoots up. So whenever they take the injection, it comes down. So then it will be like a cycle, which is not a very good process. But then if we can release the drug whenever it is required slowly, not just taking an injection in the morning, then by the evening time, so again the sugar level shoots up. So instead of that, if you slowly release it, so the sugar level will be maintained at a particular level, which is a more healthier for the patients. So these kind of things are possible. Then disinfectant robot. I think these kind of things are nowadays being very much used in COVID kind of a situation where people don't want to go near to the patients because of they getting infected. So we can have these kind of disinfectants, so where generally UV lights are used, or now we can have even chemicals put into that, and we can ask it to go and spread in the rooms or hospital rooms, or even in the operation theaters in other places where human beings don't want to go. So these are called as the disinfectant robots. So you can see the video of one of the robot performing this kind of a task.
Microbes are everywhere. As places for disease treatment, hospitals are susceptible to microbial contamination and patients are prone to cross-infection. In recent years, a large number of newly emerged multi-drug resistant bacteria, such as methicillin-resistant Staphylococcus aureus and Carbapenem antibiotics-resistant Acinetobacter baumannii, have led to frequent healthcare-associated infection, HCAIs, serious threat to human health. Reports show that 4 million people get a nosocomial infections in a hospital in China every year. The existing methods for air and object surface disinfection are time-consuming and laborious. The time of disinfection and the amount of disinfectant solution cannot be accurately quantified. The quality of disinfection is difficult to guarantee, and it is easy to cause occupational injury. Ultraviolet lamp disinfection requires manual movement and operation. Even ultra-high-intensity ultraviolet lamps can only kill very close bacteria. Bringing artificial intelligence technology into the field of disinfection, TMI Robotics Corporation has developed the world's first intelligent multi-mode disinfection robot. The TMI Intelligent Disinfection Robot takes the mobile robot platform as the carrier, equipped with 3 disinfection modules: the ultraviolet lamp, the ultra-dry fog hydrogen peroxide generator, and the plasma air filter. It can meet the various requirements from hospital. The TMI Intelligent Disinfection Robot can automatically plan a path and navigate to the destination. Based on the AI environment recognition technology, it can automatically calculate the working time for disinfection and identify critical objectives. Before disinfection, the TMI disinfection robot prompts people to leave by light and voice. Then it starts the PM2.5 detection and the plasma air filtration module. If excessive humidity is detected, the robot will turn on the drying mode to reduce the ambient humidity. If the air quality is qualified, the robot will enter disinfection mode, in which the ultra-dry steam generator starts to work. Quickly increase the concentration of hydrogen peroxide in the space. At the same time, the UV lamp starts to work. Quickly generate the hydroxyl radical. Because of its good dispersion, extra dry steam can thoroughly disinfect. During the disinfection, the robot can real-time detect and precisely control the concentration of hydrogen peroxide to guarantee excellent disinfection results. Based on its mobile platform, the intelligent disinfection robot can divide a large area into several small ones to achieve accurate and high-level disinfection. Multiple microbial killing tests have proven that the TMI disinfection robot can use standardized and intelligent means to help hospitals to reduce the incidence of nosocomial infections and meet national standards. The robot is proven to kill 99.9999% of common bacteria, including multi-drug resistant bacteria, fungi, and viruses, fully meeting the high-level disinfection standards stipulated in the regulation of disinfection technique in healthcare settings. The disinfection robot put into clinical application can shorten the disinfection time by 40% to 70% and improve the labor efficiency by 30%. The TMI intelligent disinfection robot can disinfect around the object without dead angle. It realizes the quantitative and traceable management of disinfection tasks while ensuring the occupational safety of clinical staff and nosocomial infection professionals. As intelligent disinfection platform, TMI disinfection robot achieves quantitative, information-based disinfection, traces the disinfection task throughout the process, and realizes the closed-loop management to help hospitals carry out intelligent disinfection and nosocomial infection management.
Okay, so these videos are taken so basically to see their application. So there is no commercial interest here. They are all taken from the public domain. Okay, so as we move on. So next one is a clinical training robots. So here these robots offers a more realistic, functional and easier to use learning interfaces. I don't know whether you know this. Generally, whenever the surgeon makes a surgery, if it is a complicated one, unique one, and for the first time if they are doing, for example, if there is an heart patient and some procedure need to be carried out which they have never done before because it is a special case. So what they do is, actually nowadays we have rapid prototyping or rather additive manufacturing techniques, where they make the same, they take the scan, then make the heart same like that by using a different materials, and then they cut that material and practice the surgery, because the time available to carry out the surgery will be very specific. See, when they stop the heart and then use the lung heart machine, so you cannot just keep it for quite long time. So something like 1 hour or even less. So before that, they need to complete the surgery, stitch everything, and then make the heart to function again normally. If it is delays and all, sometimes it will never restart. So it's a very, very risky kind of a process. So to make it to do it faster, they first practice on these kind of a dummies, and then later they do the actual surgery. So in that kind of a cases, the training robots will help in making and doctors to feel the realistic thing, like even how much is the pressure they need to put. So if they put excess pressure, the tissues below it or any parts below it will be get cut. So that is the reason the surgeon scalpel, they need to handle it very nicely. Like for example, if they want to cut the skin, only at skin level they need to cut it. They put it sharp and then just cut it roughly. the organs inside will get damaged. So they don't do that. They just cut it exactly to the depth what is required. So all these things can be practiced with the help of the training robots. And another robot which is being used is called as a companion robot. So generally and specifically now in COVID patients, so nobody can go near, even though parents are there, their loved ones are there, but nobody will be allowed to come near. So the patients already they are sick, they'll be afraid what is going to happen, and there are nobody to care for them. Nobody comes near. Even when people come near, they stand at a distance, so give something and go away. So they feel very desperate. So in that kind of a cases, these robots will act like a friends. So maybe like a doll shape or whatever. If somebody likes a teddy bear, so make that robot in the teddy bear shape and then give it to them. So it talks and then interacts with the patients and gives them company for 24/7. So thus, there are different types of robots. Alexa is one which speaks and then tries to give you company, but you can make it in the form of a doll and then make it feel more realistic. Then the other one, telepresence robot surrogates. So here, generally what happens is, we'd have seen, like even in a mechanic, if you go to a shop, sometimes it is a simple job. The main mechanic will not do the job, but he'll be standing there looking at the junior person or training, the person who is getting the training, and he'll be telling them whenever they are doing wrong, they'll say, okay, do it like this, that. So even the medical also, it's like that. When younger surgeons are carrying out a surgery, the senior doctor or an expert doctor, he may not be physically present there because of distance and other things. So now we can have a tele-robot where it will represent exactly like the same robot, the same like the expert surgeon. He'll be there in the operation theater looking at what these people are doing. And there in the remote place, the surgeon also will be looking there and he will be guiding them. So in case they are going wrong, so immediately this robot will intervene and then tell, so do it like that. So thus telepresence. So they are almost like an expert is present in the surgeon, present in the surgery room or operation theater. So many times we'll feel comfortable when our guru or like a senior mechanic or a senior surgeon is with us, or even sometimes when our teachers are there with us, we do the work confidently. So thus the telepresence robots will help in that way. And then robotic nurses. So all the functions which the nurse will be doing, so the robots can do. So me, rather than explaining it, you can look at this video and understand it much better. So thus, whatever the job done by the nurse, so the robot can do. And then robotics. So actually, if you look at the warehouse, even for generally in industry or even in pharmaceuticals, so there are big kind of packages you can see here. So they'll be stacked like in a 3D space to pick up something what is required, or even in a pharmacy. So when you go to a medical shop, so the person looks at the slip, then goes and picks up the right medicine and then bring. So if there are people who are newly appointed, they'll be keep searching all the racks for the medicine. And then the senior person, experienced person will come and tell, oh, not here. go look there, so he can find that medicine and he can bring. So these robots can actually help in picking out that kind of the right medicine. So wherever it is located, it can know and then it can bring and give it. So thus they are much helpful. In industry, we call them as ASRS systems. So ASRS is nothing but automated storage and retrieval systems. Automated storage and retrieval system. So the same thing even for pharmacy. And these days the medicines need to be stored at minus degrees. So lower temperatures, even the robot can go inside. But a human being to go into minus 70 degrees temperature, like COVID vaccines, some of them need to be stored at that kind of a temperature. So you can't go inside and then bring it. So we can send the robots and ask them to bring. So all these functions can be done by the robots. Then the next one, the diagnostics. So usually like when you do the blood test and other things, so we need to diagnose what is wrong. So even that can be done by the robots. So they have nowadays actually a lot of data mining kind of functions are done, though there is a large amount of geometrical data and then reading from several instruments. So it is possible for the robot to analyze it and then say, like for example, if you take a patient on an emergency, so first they'll connect all the things. So they'll read the pulse, they'll check the breath, they connect the machines and continuously monitor that. Then by looking at all the readings, doctor can say what is the state of the patient. So even here, the robots can get all those signals and analyze, and they can tell what is the issue. So this is called as artificial intelligent diagnostics. Then robot assisted biopsy. So it can do surgeries, it can do biopsies, but this particular robot was designed to do the biopsy, to take the sample from the heart and then use it for testing. Then the next one, AI epidemiology. So where this kind of epidemics, so viral infections analysis and presence of these kind of viruses, so the systems can see and detect them and caution, and also you have seen in cleaning those things, so we can use the artificial intelligence. So these days actually to find out the medicines and the vaccines, they study the whole DNA structure and a lot of data will be generated, so that can be analyzed by using artificial intelligence. Then the 15th one, so antibacterial nano robots. So we can send these small robots inside the blood vessels, and then they can carry out the work for which it is intended. So a small robots, so it will go into the platelets and then they can carry out, clear the bacterial infections or even remove the fat which is deposited on these blood vessels. So if the fat is deposited, they can go and remove that. So they'll be so small that it can go into the blood vessels wherever it is required and carry out the functions. So there are several advantages of these medical robots. So even the diagnosis is very fast. So earlier and all, if you take a CT scan, till the doctor reads it and tells, we will not know what it is. But nowadays we see that the report, initial report is generated immediately, because the robots or the artificial intelligence system analyzes it and gives the first report. So later doctor comes and looks at it and then he will give the final decision. So then the robots doesn't get tired, they won't get infected, so you can use them wherever you want. Okay, so we'll see some of the robots, how they are carrying out these surgeries, and then we'll close.
A robot operates on a medical emergency. A scene from a science fiction film? The fiction has long been a reality. In the hospital, the robot becomes the perfect teammate of the human being, like the Da Vinci. We can preserve fine structures. We have a three-dimensional view.
We have a tenfold enlargement of the surgical area. We have instruments that are superior to the mobility of the human hand, and we can operate without shaking.
Und wir können zitterfrei operieren.
No wonder that medical robotics is booming. Employees at the German Aerospace Center are developing a robot that will revolutionize surgery in the future, the Miro. Thanks to its lightweight construction, it can be integrated into the operating theatre in a very space-saving way. Furthermore, the research also includes the fact that even more can be discovered about the patient's insides via miniaturized sensors. And this information actually corresponds to the different senses of the surgeon. So it's tactile, haptic, auditory, and also visual. This also improves patient safety. Suppose the hand of the doctor ever slipped off the controller. A life-threatening scenario. Not with the Miro. It can be programmed in such a way that the patient's organs are not put at risk. So it would not carry out an accidental movement by the doctor. So will doctors soon become superfluous? After all, more and more machines are being developed that will work autonomously. The robot arm at the Fraunhofer IPA, for example, is designed for tissue sampling. The experts agree, however, that the medicine of the future will always need experienced doctors. Robot-supported assistant systems in medicine are just that, tools that assist. So a doctor is always fully responsible for the entire procedure, and the robot is merely a tool.
Hello, I am Dr. Fernando Diaz. At Beaumont, our neurosurgeons are known for giving our patients the most innovative and minimally invasive options for surgery, and that includes robotic-assisted surgery. Robots assist surgeons in placing the instrumentation in a very precise way. In neurosurgery, we primarily use it for spine surgery. The basic idea of the robotic technology is similar to what you use in your car with GPS technology. The precision comes from planning the surgery ahead of time on a computer. We tell it exactly how we want the instrumentation to be placed. Then the robot helps reproduce the same planned surgical approach with the GPS technology that in surgery is called stereotactic guidance. Beaumont neurosurgeons are now using the Maser X robotic technology in thoracic, lumbar fusions, and in sacroiliac joint fusions. It also can be used for the treatment of tumors or cases involving spine fractures of any type, or an application for degenerative changes of the spine. This tool allows us to accurately and safely place the instrumentation we use during your surgery. Once the planning is complete and we know exactly where to place the instruments, the Maser X saves the instrumentation during surgery. The Maser X reproduces the same plan with precise stereotactic navigation by recreating the planned trajectory for the patient during surgery. The benefits of this technology to our patients are: number one, a dramatic reduction in radiation exposure because we are able to limit the use of X-rays. Number two, a customized surgical plan for each patient before going into the operating room. Number three, increased accuracy and safety in the placement of the instrumentation. Number four, less time to complete the spine surgery. And number five, a reduction in potential complications resulting from misplacement of surgical instruments. So you can see, the Maser X technology provides our patients many benefits to improve outcomes. If you have any questions about the technology or any surgical option at Beaumont, please be sure to talk with your surgeon.
Okay, so though there are several challenges, so there were some issues with already existing robots, but still, so we have been seeing that more and more these robots are being put to use in practice and being implemented. So if the technology is even perfected, so we see the whole revolution in the medical field, so which is already been happening. So thank you for your attention, and if you have any questions or if you want to interact, you can do that. Thank you. Any questions?
Hello.
Yeah.
Sir, is it over, sir?
Yeah.
So participants,
They
sir,
want.
is any inquiries about the applications of robots? Please.
Very good afternoon.
Hello.
Any questions?
Sir, good afternoon, sir.
Yeah.
Sir, is there any application for agriculture field of this robotics, sir?
Yeah.
Special applications, sir?
Yeah, I think nowadays AI, artificial intelligence, and robots have been used to every field. So agriculture also they are doing it. See now, one important thing is even the prediction of the rain and the climate is one of the primary thing. You know, the farmers working on the field is one, but they used to wait for the rain and then they need to sow the seeds in the right season and during the harvest if it rains so the grain get damaged. So all these problems are there, but now by using the artificial intelligence system, so people are able to predict. Yeah, we are able to predict the climate almost accurately, so which actually helps the farmers. So that is the first step. So next one, using the not exactly robots, but they are advanced implements. They can actually do the farming much effectively. And even actually one of the IIT alumni has developed a, it's not a robot or a device which can milk the cows. So which used to be a very tedious process if it is done by the humans. And because of that, they are able to get a very good yield. And then in a very short time, they are able to get get the milk. So these are some of the technologies, and even in farming, a lot of technologies are being used. So even to spray the disinfectant, so we can have the robots. So even to kill the what do you call the infectious these things, so they use robots, like they are more like an advanced devices and instruments with intelligence built into it. So you may not have like a shape of a robot walking on a field, but with a required kind of a shapes, so you can test the soils, you can decide what should be the type of fertilizers, then you can even help in digging the ground, all these kind of things. So thus robots are being applied to almost every field, whatever you name. Yeah. Anything more? Any other questions?
Sir, small request, sir.
Yes, sir.
Within 1 or 2 minutes, we are going to take group photo, sir.
Okay.
That is going to be uploaded to Aicte Atal.
So how you are going to take physically, you mean, or virtual?
This grid video, sir. All are open their videos.
Okay.
Okay, all coming onto the screen. Then we can take one photo and
a screenshot we can take and then use it. Okay, good.
Just wait for 1 minute, sir. So all participants are requested to open your videos, please.
Actually, we can tell them even during the lecture, if they can all open it, that will be more interactive. But maybe bandwidth is yeah.
All participants, please. Hello, sir. Welcome, madam.
Just a minute, sir.
Otherwise, people will be sitting behind the screens.
All are requested to unmute and open your video, please. Sir is waiting.
And you can adjust it. Yeah, you can sit in such a way that the light can fall on your faces and then not a bright background so that your face can be seen clearly.
So once again, all participants, please come onto the screen. Please open your video. I request all participants, please. Be open చేసుకోండి. అక్కడ వచ్చేసింది చూడు. సార్ విత్ పార్టిసిపేషన్. ఓకేనా? ఇప్పుడు బాగుందా? మేడం చూడు ఒకసారి. అక్క వీడియో ఫోటో తీసి ఓకేనా? Okay, sir. Okay, sir. Yes, sir. Thank you. Thank you so much, sir.
Yeah, okay, sir. Thank you.
Okay, just before going to conclude my words, today's second session on medical applications of robots by Dr. G.L. Samuel, sir, Professor, Department of Mechanical Engineering, Narayana Engineering College, Nellore, with the kind support, guidance, and cooperation of our G.L. Samuel, sir. We have started our FTP with SAR lecture, starting lecture on introduction to robotics, and also end this FTP sessions with applications of medical applications of robots. Sir has given a clear information about so many practical medical applications for robots in surgeries and other areas. I hope all participants gain much knowledge in this particular concepts, and anybody want to do their research work in this medical field, definitely all these lectures are very much helpful to the faculty. And also my sincere request to all the participants, please share this information to your colleagues and as well as students community also. Once again, thank you, sir, for your valuable and kind cooperation. Thank you, sir. Thank you so much.
Okay, thank you.
One more
Wish you all
request
the
to the
best. Yes.
participants. Today at 2:30, we have a test as per AICT Atal Academy norms. All are requested to attend 30 minutes test. Okay, whatever the syllabus covered by our resource persons during this days, please ready to attend test for 30 minutes and also validity question follows after the test. Once again, thank you, sir. Thank you so much.
Okay, thank you. All the best.
Thank you, sir.
Yeah,
Thank you very much, sir.
Thank you. Congratulations to the organizers for successfully conducting it. Thank you.
Sir. It's only with your cooperation, sir.
No, thank you, sir. It was nice.
Cooperation, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Yeah, thank you.
Thank you,
Bye.
sir.
Thank you, sir.
Thank you, sir.
Hello. Hello. హలో
हेलो सर
మేడం గారు ఈ రోజు ఎగ్జామ్ ఉందండి
हाँ कब है
ఎన్ని గంటలకు ఉంటుంది ఎగ్జామ్
you are sending the link for exam
yes I did not get any link from you
I'm one of the participant
acha okay madam okay. Is there any administratives
no one is there
no one is there okay madam right
any announcement done before
Hello.
Hello, participants.
hello
Madam. Hello.
Yes, ma'am. Is there any announcement?
Hello. Good afternoon to all.
Good afternoon.
Madam, the test will start exactly at 2:30.
Yes, sir. Yes, sir.
We will send
Continuation in the morning session, sir.
we'll send the link, madam, to your mail and through WhatsApp.
you are sending the link on mail
Mail and WhatsApp.
okay at 2:30
Exactly at 2:30.
okay
Now there is no session, sir.
Will be shared.
Sir, what is the duration for the exam, sir?
Sir, actually it consists of
Half an hour.
the duration is 30 minutes, sir.
Sir, already told
us, na? 30 minutes.
Okay, sir. Okay. So you'll be sending a link through mail, am I right, sir?
Mail and as well as WhatsApp.
Okay, sir. Okay, sir.
Hello,
Thank
sir.
you. Thank you.
Hello, sir. How many questions will be there?
25 questions, ma'am.
25 questions.
And the duration is 30 minutes.
Okay.
Is there any doubts?
What is the level of question, ma'am? The difficulty level of that?
All are fundamental concepts.
Fundamental.
And from the sessions, sir.
Excuse me, sir.
Okay, ma'am.
Excuse me, sir. I was not added in the WhatsApp group, so please send the questions in the mail also.
Yes, sir.
Yes, sir. That is what with me also. I was not added in the group. I got mail and through that I got the admission.
Okay.
and from yesterday also we are not getting the feedback link
Yes, ma'am. Already yesterday I sent, but only for the sessions of 13 and 14 I have to send.
no last I am already sent the mail yesterday also.
I was also not getting the feedback link because was not in the WhatsApp group.
Yeah, I am not attached with the WhatsApp group, and that's why I'm not feeling the feedback form for session number 9, 10, 11, etc.
Okay, I also didn't get the feedback link because I am not added.
You send through the mail only. Okay.
And I sent the mail also related to that. I'm Sangeeta Patil. I'm sending the related mail also.
Okay,
Madam. Okay.
Madam, I did not got any session feedback.
What, ma'am?
I did not get even once. I did not get even one session feedback form also.
Madam,
I also didn't get any feedback from mom.
check your mails, madam. Once I will also check. Okay.
Also, I didn't get any days. Yet I didn't get. I checked.
I already sent, madam. Okay, I will check.
No, ma'am. No. Yesterday, someone has sent me only the PDFs. 1 minute, madam. This is Madhuri speaking. Yesterday, someone has sent me the PDFs.
231
Okay, about the program. I got the PDFs.
231 link.
And whatever the remaining links, I did not get even one feedback from 15th onwards. I am participating because on 14th I did not get the registration link. I have mailed to you, and someone has sent me the registration link. I am admitting through the registration link of the mail.
Okay, ma'am, I am Sita Radharishnan. I also sent a reply to the HOD that I was not added in the WhatsApp group, and I didn't even get any feedback link
I
for
sent,
any day.
madam. Okay, actually, I sent the WhatsApp link to you. If you want to join in that one, you may join through the link. Actually,
Madam, just share that on a email, mail.
Mail. Please share the feedback link on the email, ma'am.
We are every day, every time we are there.
Madam, can you please take our WhatsApp number and add in the group?
Okay.
Madam, I will send the link to your mails only now. Okay.
Once again resend the link, ma'am, because I got only the PDFs which are related to the program, but I did not get any other links. Only one Facebook link and one Zoom link I got on 15th morning, so that I have admitted through that.
I also got that Facebook link and the Zoom link. I also didn't get any other link.
WhatsApp, I sent only WhatsApp link and Zoom link, madam. Not the Facebook. Okay, I will check and again I will send, madam.
My name is Sita Radharishnan, ma'am.
And my name is Madhuri Sakti.
Okay, ma'am.
Hmm? 87. Direct second year पूर्णच 87. हा? हो, ते काही लोकांना नेटचा प्रॉब्लेम. Hello. Hello.
Hello.
Sir, I also not get the feedback link. I am Padmakar Raut, DAY5.
Not get a feedback link.
Yeah. And my number is not also in WhatsApp. I didn't get.
What is your number? Phone number?
Padmakar Raut. And phone number is 9518772912.
8 minutes, sir, please.
18.
Yeah.
77.
Okay.
2912.
Your good name, please.
Padmakar Raut.
Padmakar Rao. Okay.
Yeah. And also my colleague is there, Patil JK PVIT.
Okay.
He didn't get the feedback thing also.
We'll check up and we'll send again, sir. No problem.
Okay.
Sir, I am Sridhar Radhakrishnan. I also didn't get the feedback link of any day.
You get that one, madam. Already you told.
Okay.
I will share the phone number of JK Patil, Mr. Patil JK PVIT.
Oh, please tell me.
9702.
Okay.
16.
16, sir?
165533.
Okay.
Okay, thank you, sir.
Okay, sir.
മുകളിലൊക്കെ ചോറ് മാറ്റിട്ടേ അടിയിൽ നിന്ന് അടുത്തത് വാവേ അത് കൊണ്ട് കുത്തി വെച്ചാൽ ഈ ചമലത്തൊക്കെ കൊണ്ട് കുത്തി വെച്ചാൽ ഇവിടെ കുറെ കുത്തി വെച്ചേക്കാം ഇപ്പൊ ഇപ്പൊ ഇവിടെ ഞാൻ വെട്ടിക്കളഞ്ഞ കൊമ്പൂല അതെ ഞാനൊരു കാര്യം പറഞ്ഞത് എനിക്ക് പരീക്ഷ കാണിക്കില്ല അവൻ കണ്ടോട്ടെ ഓക്കെ അവൻ കണ്ടോട്ടെ ഞാൻ കേട്ടില്ല പലപ്പോഴും ഞാനൊന്നും കാണാനിരിക്കുന്നത്
लिख के कब भेजूं इसको?
Hello, sir. Hello, sir. Hello, sir.
Yes.
Madam.
Sir.
Madam, after submitting this particular Google form,
Okay.
is there any provision to get a mail from your end?
I will send, sir. Actually, from the Atal, sir, you receive a certificate, sir, regarding this one.
No. What I mean to ask is, we have already submitted. Are you going to give any response mail based on the submission completed, something like that?
Not like that, sir. You only get the marks and it's taken in a spreadsheet, sir, actually.
Yeah, ma'am. That
Okay,
means
I will send, sir. I will send that one.
any specific criteria that we qualified in this mark, something like that?
Actually, as already told you at the beginning and already mentioned in brochure also,
sir,
participants who have attended for 80% more than attendance,
sir,
and also who have secured more than 60% marks in 60% more than marks in the test,
sir,
they will get online participation certificate from Atal, sir, directly.
Sir.
That is the
Sir, actually, due
already
to
noted in the brochure and repeated times during this FDP program, I informed to all the participants, sir.
okay, sir. Because okay, sir. Okay, thank you. Notified. Okay.
Sir, I am Sita Radhakrishnan. I have attended all the sessions, but I didn't get any feedback
Madam,
form.
Okay, some gap is there. We will send whatever you could not receive. Just inform me. Again, we will send all the feedback forms to you, madam. Don't worry.
Okay, I am not in the WhatsApp group, sir. That is why.
I sent through mail also, madam.
Not only WhatsApp, we
okay.
Both mail and WhatsApp. You already sending all the feedback forms to mail and WhatsApp. Both. Please go through your mail.
Sir, I didn't get the mail. I got only the brochure. Now I got the test link. I attempt the test.
That mail only I send the feedback link also, madam.
Okay. Please send me once again.
Okay, madam.
Okay, thank you.
Hello.
Hello, good afternoon, sir.
Hello, sir.
Sir, this is Ash.
Hello.
Formality after completing the quiz.
Sir, validity function is there, sir, generally.
Actually, I want to know about the feedback link of the last two sessions.
Sir, already I sent it through the mail and WhatsApp now.
Okay. Thank you, ma'am.
Good afternoon, ma'am. I'm Sita Radhakrishnan. My email ID is sita.radhakrishnan@saintgirs.org. I didn't get the my feedback link.
Actually, now I send the test link to the mail. To that mail,
Okay.
I send the links also, madam. Feedback link also.
I got the test link. Test link I got from mail, but I didn't get that feedback. I will send a reply to you. From that, I will send a reply to you for the test link.
Check once, madam, again.
Madam, just after just 2-3 minutes, we have complete this validity function.
Okay.
After that, we will go through the mails and whatever the inquiries from you, will take care of it, all the inquiries, and will solve your practical problems, madam.
Okay. Okay. Thank you, sir.
Okay. Okay. Yes. Okay. Okay, good. Once again, good afternoon to one and all. Today, this is the time for validatory function of this 1 week faculty development program on robotics, sponsored by Atal Academy, AICT Training and Learning Academy. First of all, I would like to express my congratulations to all the participants who have qualified written test, which already conducted by AICT Atal team regarding this certification of this FDP. And on behalf of Department of Mechanical Engineering, Narada Engineering College in Nellore, warm welcome to our chief guest for this validatory function, Dr. V. Veeranagaru, Professor, Principal, St. John's Engineering College, Emigano. You all know very well that Sir has covered 2 sessions. Today, morning session, already covered by Virana sir regarding this reconfigurable robots. At the outset of this program, I am very much grateful you, sir, for your valuable support, presence, and acted as a chief guest, readily accepted our request, acted as a chief guest for today's validity function, sir. Thank you so much, sir. And yes, on behalf of Narayana Engineering College in Nellore, first of all, we are very much grateful to Aicte Atal Director, Dr. Ravindra Kumar Soni ji, Assistant Director, Dr. Girdhar Lal Garg ji, Gaurav Singh ji, Rahul ji, and all other Atal team members for selecting our college as a center for organizing such a valuable, wonderful event on robotics in this region. And also, as already told you, the success and failure of any program mainly depends upon the participants. No doubt, during this 5 days journey, I'm very much grateful to all the participants for your support and active participation in all the sessions. As we already covered so many topics, so many lectures by eminent professors from IITs, NITs, and universities and reputed institutes. And some of the topics I used to mention on 14th, Introduction to Robotics by Dr. G.L. Samuel sir, Professor IIT Madras, and second section by Robot Kinematics by Dr. Vijay Kumar Dalla sir, Professor NIT Jamshedpur. Sir also covered inverse kinematics and robot dynamics, and Dr. V. Virana sir, Professor, has talked about robot modeling and simulation on 15th, and again today sir has explained about reconfigurable robot. And one more topic, robot sensors and actuators by Dr. V. Venugopal Reddy sir, Professor, Head of the Department of Mechanical Engineering, JNT Pulivendala, Andhra Pradesh, and wonderful lab sections covered by industry expert Mr. SD Parvez Hussain, Technical Manager, II Club Hyderabad. 2 sections have been covered by Parvez Hussain sir. One is robot vision and another one is lab section on robot components and assembly. And one more lab section on robot control using teach pendant by Dr. V. Venugopal Reddy garu, Professor and Head, Department of Mechanical Engineering, JNT Pulivendala. And one more wonderful section, that is stress management, taken by Professor Bhanu Prakash, spiritual mentor and counselor, ISKCON Bombay. And also the test already completed, and already the site will be opened up to 10 o'clock today. If any participants want to appear the test, please utilize this opportunity. And as already told you, as per Aicte Atal Academy, every participant should attend at least 80% more attendance and also secure more than 60% marks. Then only the participants will get a e-certificate. Now, on behalf of our college and Atal Academy, I am welcoming you, sir, Dr. V. Virana sir. Please give address to the gathering. Thank you, sir. Please. Sir, unmute చేసుకోండి sir, please.
No.
Yes, it is okay, sir.
Okay. Now it is okay. Good evening, all of you. Good evening, all of you. I'm very thankful to the Narayana Engineering College management and principal AVS Prasad Garu and coordinator, convener Dr. AVS Sridhar and co-convener Nagamani Garu. Under Atal AICTE training and learning program, the AICTE is organizing a series of workshops for the benefit of staff and students. So hope all of you utilized this workshop for your benefits. So what I want to say is teaching is learning. So I have taken two sessions. One is modeling and simulation. In modeling and simulation, due to technical problems, I don't know. So some problems I happened, but is a teaching is a learning. For the second session, with the technical support, I learned that there is a problem, and I learned the technical problems can be solved. So what I say is teaching is a learning. Learning leads to knowledge. Knowledge is power. So all of you will have a benefited with this workshop. All the participants can not only the teaching career, so some of you can go for the research work. So in these almost 5 days means 15 sessions may be benefited a lot for all of you. So thank you very much for the organizers once again. So I thank all the participants for their cooperation and patient learning. As a teacher, I'm very happy for this. So I'm thankful to management once again. Thank you, sir.
Okay, sir. Thank you very much for your valuable words as a chief guest of this validatory function. And once again, thank you all the participants. Do you have any inquiries? You are knowing my phone number, email address, coordinator and co-coordinator. At any moment, you can ask any doubt, any problem what you are facing in any aspect. You always here to give full support to you all. Okay, once again, thank you so much for your support. Thank you, Virana sir, and thank you so much all the participants. Okay, thank you.
So is there any feedback from the participants, sir?
Madam, when we will get the certificate, madam?
Sir, maybe 1 or 2 days, sir.
Okay, thank you, madam.